Welcome to this plenary session in GRA6036. Today is Monday, March 16th, and we'll do some assignments from some previous exams. So we'll start with the final exam from last year, and you can find that exam on It's Learning on the previous exams, and it's this exam right here. So we scroll down to assignment 3, and we'll start with exercise A. So in this exercise, as usual, we're given some data, and we're given a function, and we're asked whether the mean of GXI, so when we apply the function to each of the data points, if the mean of those is equal to this function applied to the mean of the data points. So to be more clear about what that means, so first, we have some data. It's usual, denoted by x with indices 1 up to n, and we are given a function. So our function is the linear one, so it's equal to a times x plus b. So this is the function, and we use this function to transform each data point. So we apply this function g to each of these data points, and that will give us sort of a new data set or transform data sets. So we apply g to each xi, giving us the data gx1 up to gxn. Okay, so this is the new data. Now, as usual, we denote the mean of the data. So of the data, or so here of the xi's by bar xn, which is 1 over n times the sum of the xi's. Okay, so that is what we used to, and we can now state the question. The question is whether it is true that when we apply g to the mean, we get the same thing as we get if we take the mean of each of these guys. Okay, so we'll leave a question mark after this, because this is the question and exercise, and we are to see if that is true. Well, it is true, so we'll now prove that it is true. To do so, let's first think about what g applied to the mean is. So g applied to the mean is, of course, a times the mean plus b. So we see that. So that is just by taking the mean and inserting it here, and then we get this. Okay, so now we'll do this sum step by step to see if we get g applied to the mean of the x's on the right hand side. So okay, so here's the mean. So the first thing we do is that we replace gxi by a times xi plus b. Okay, so we just insert the definition of g. So then we take a parenthesis outside, and we take a times x plus b. So that is just inserting the definition for G. Now, next step we can just use, we should remember that there's a constant outside, and then we use the definition of a sum inside these parentheses. So we then have a times x1 plus a times x2, and then we do the dots up to the last term. So then we get this just by using the definition of a sum. Okay, so now we can rearrange things to make it clearer. So first we can place all our ax's after each other. So we then take ax1 plus ax2 all the way up to axn, and then we get 1b, 2b, n b's. So we can then multiply b by n, and we get this. So here we see that a is common to all these x's, so we can take the a, we can wrap the x's into a parenthesis and take the a outside. So let's do that. So that means that we take a parenthesis here, and remove this one, and we remove that one, and end the parenthesis. And we should have an equality here. Okay, so now we recognize that here is the definition of the sum of the x's. So we can then replace all those x's by the summation sign of those x's. So then we have a times the sum from I is 1 to n xi. And now we can take the 1 over n and move that inside these curly bracket parentheses. So when we do that, we'll get a over n times the sum of the xi's, and this n will fall against this n in the denominator. So which means that we'll have a times 1 over n times the sum plus b. Still forgot about the equality. And now we see that, well, this is the definition of the mean of the xi's, so that's what's up here. So we can now replace this mean by this x bar symbol for the mean. So if we do that, we get a times bar xn plus b. But now we see that this is g evaluated in the mean of the x's, which means that we have now shown what we were asked to prove in this assignment 3a. So we can now remove this question mark. Now we've shown that this is true. Okay, so in the next video I'll do exercise B.